Hi. The next study design I want to discuss are the cross-sectional studies. Now, what's special about a cross-sectional study is that dietary intake and the outcome are assessed at the same time. You could just think of a cross-sectional study as a snapshot of a group of people at a given point in time. Now, imagine that we would like to know if the consumption of diet soda may be helpful in body weight control. And to address that question, we would recruit a large number of subjects and ask them about their normal intake of diet soda. We would have the subjects indicate how often they drink diet soda and in what quantities. We would also measure their height and their weight to determine their body mass index as an indicator of the degree of obesity. Now, because diet soda contains very few calories compared to regular soda, the expectation is that people that drink a lot of diet soda will have a lower body mass index because they probably consume less calorie-dense regular soda. And we just expect a negative correlation between intake of diet soda and body mass index. But there is a good chance that we may find the exact opposite, which is people with a high intake of diet soda have a higher body mass index. So how is this possible? Does it mean that consumption of diet soda promotes obesity? Not quite. Because in cross-sectional studies, exposure and outcome are measured at the same time. As a result, the exposure could be the consequence of the outcome instead of the other way around. In our example, the most likely explanation is that people that have a high body mass index are more likely to switch to diet soda in an effort to lose body weight. And their high consumption of diet soda is thus not a cause, but a consequence of obesity. And we call this very important phenomenon reverse causality. Now, the inability to determine which comes first, the exposure or the outcome, is the main limitation of cross-sectional studies. But I should point out that if the outcome is a parameter that people cannot sense or don't know about, like plasma cholesterol or blood pressure or blood hemoglobin levels, the direction of the relation is more or less fixed. For instance, if we find that people that have a high intake of processed foods have a higher blood pressure, meaning that there is a positive correlation between intake of processed foods and blood pressure, it's highly unlikely that the higher blood pressure led people to eat more processed foods. But keep in mind that, like all other observational studies, cross-sectional studies merely reveal an association and cannot say anything about whether that relationship is causal. People say correlation is not causation. Now, cross-sectional studies are very popular in nutritional science, but they should be treated with caution. Similar to other observational research designs, cross-sectional studies are prone to something we call confounding, which is explained further in the context of case control and cohort studies. Unfortunately, a major portion of the confounding can be removed during the analysis of the study. So, in short, in cross-sectional studies, the exposure and the outcome are measured at a given point in time. The biggest concern with cross-sectional studies is reverse causality, which is mostly avoided when examining the relation between dietary intake and a biomarker, such as cholesterol level or blood pressure.